All right, good morning, everybody. Last week, this is it, huh? Last week, hopefully everything's in. Hopefully you guys are doing great. Hopefully there's no F's. Hopefully we're all doing well, okay? Anyway, let's take a look at an application to the law of sines or the law of cosines, okay? So, here we go. Let's read through this. Two ships leave port at the same time. Ship A travels at a bearing of north 25 degrees toward the east at a speed of 12 knots. Knots is like the speed of a boat, okay? Ship B travels south 40 degrees towards the east at 8 knots. Okay, that's the speed. Draw an accurate scale drawing of the journey. Now, you guys may or may not have rulers, protractors, all that good stuff, but I do. And I'd be willing to help you out if you guys don't. So first of all, the boats are kind of going this way and this way. I'll show you what I mean. So let me put, first of all, I like to call it the compass rose. Call it whatever you want. But this is north, right? And if I want to go 25 degrees towards the east, I'm going to point north and go 25 degrees to the east. So if I go north, 25 degrees towards the east, then I'm just going to go north, which is at 0. I go 25 degrees towards the east, 10, 20, 25. So I'm going to go that, head in that direction. Okay, now, what I'd like to do is draw my boat. So my boat is going about 8 knots, right? No, 12 knots, sorry, 12 knots. So if I use my ruler, and if I use centimeters to represent, oh shoot. Well, let's take my darn drawing. I don't have any white out, so we'll just do it down here. My bad. Okay, we'll do it again. It's going to fit there. Shoot. Okay. All right, here we go. 25 degrees towards the east. All right, 10, 20, 25. Okay, now it'll fit. Here's my north. So 12. I'll go 12, which is about there. 12 knots. So here's my ship A. All right, this is better. Okay, what did I do? I made a 25-degree angle with my protractor, okay? And I measured this to be 12, okay? Then what am I going to do? Well, from there, and that's going to be 12, right? Ignore that. Darn me. So then the second ship, this ship A, second ship, ship A is going to go for south. He's going to point south and 40 degrees towards the east. Okay, so let's see. South, 40 degrees towards the east. Okay, so I'm going to look south. Okay, so take my protractor. I'll look south. Okay, zeroed out south. And I'll go 10, 20, 30, 40 degrees towards the east, right? Because that's the east. And then this one is 8 knots. So I'll use my ruler and I'll draw it 8. And I'll put boat B. Here's boat B. Okay. That was 40. So let's get the rest of these angles. So that's got to be 65 degrees to make 90, right? 90. And that's got to be 50 degrees. So the angle between the boats, let's see, that's going to be what, 115, right? 115 degrees between the two boats. So how far away are the boats from each other? Well, that would be this distance here, okay? So this is the distance here that they are from each other. Okay, let's call that D, okay? So boat A takes off 25 degrees towards the east, pointing north. Ship B points south, and goes 40 degrees towards the east, okay? Got my 90, so 50 degrees and 65 degrees to make 90. And then the distance between them is here. So now they're going to go for 3 hours. So instead of just drawing this longer, let's just keep the same and multiply it by 3. So this is going to be 36. This is 8. We'll times it by 3. So this will be 24. Okay. Now, let's see what we have. We do not have a pair of opposites, but we have a side angle side. So if we have side angle side, we're going to use the law of cosines. Okay, law of cosines. I use the law of cosines, which is, and I'll say it, but it should be in your notes, opposite squared. So this is my opposite, right? That's got to be my opposite. Here's my angle. It's going to be opposite squared is equal to adjacent squared, 36 squared, plus my other adjacent squared, 24 squared, minus 2 times my adjacent, which is 36, times my other adjacent, which is 24, times the cosine of my angle, 115 degrees. Okay? So, and that should be in your notes. Opposite squared equals adjacent squared plus the other adjacent squared minus 2 times your adjacent times your other adjacent times the cosine of your angle. Okay, we learned that last week. So then I'm going to put that in my calculator, okay, just the way it is. I'll put this part of it into my calculator, okay, and then I'll take the square root of it because it's d squared. So here we go. We'll go 36 squared plus 24 squared minus 2 times 36 times 24 times the cosine 115 degrees, and I get an answer of 2,602, which is way too long, way too long. I mean, but what we have to do is take the square root of that, right? We're going to take the square root of that answer, and there we go. I get about 51. So I had d squared equals 2,602, but I took the square root of both sides, right? Square root, and then I got it to be about 51. Okay, there you go. 51, and that would be in terms of knots. Okay, there you go. All right, no problem. Now let's turn the page. Oh, by the way, the extra credit is if this ship becomes disabled, then this ship has to find him. What is the bearing? So then the way you got to find that little angle there. But anyway, that might be the extra credit on the test. So next one, find the area that's quadrilateral. Okay, so it's still the same kind of material. All of our problems are triangles. They're all triangles, right? So I need to make a triangle. Either I can cut it here and make a triangle there, or cut it there and make a triangle there. It doesn't really matter. So what I might do, let's cut it there. Why not? Cut it there. So what I have is two triangles. Triangle 1, and I have a triangle 2. All right, area. Let's see. There is an area formula. It's 1/2 my adjacent times my other adjacent times the sine of my angle, right? So triangle 1 should be pretty easy because here's my theta. Here's adjacent 1, adjacent 2. So triangle 1, its area is 1/2 my adjacent, which is 28, times my other adjacent, which is 25, times the sine of 110 degrees. Okay, and I'm just going to use my calculator. See what I get. So clear, 0.5 times 28 times 25 times the sine of 110 degrees. About 328.9. Okay, 328.9 centimeters squared. Okay, so I'm going to circle that and come back to that. Okay, now if I want the area of the whole thing, then triangle 2. The problem with triangle 2 is this. I want to use side angle side, but I don't have that. I need an adjacent, so I have this 20, but don't have this side, okay? 1/2 adjacent times adjacent, I don't have the side, so let's call this side just C, okay? I'm going to call it C. Alright, so I've got to use my other triangle to find C, and what I'm going to have to do is use the law of cosines to find C, okay? Law of cosines because I've got side, angle, side. So I'm going to go law of cosines. So we'll set off little c squared is equal to adjacent squared, 28 squared, right? This is this formula right here, right? That's this formula here. Adjacent squared plus my other adjacent squared minus 2 times my adjacent times my other adjacent times the cosine of 110 degrees, okay? 110 degrees. And I'm just going to put that in my calculator, do the math, with the calculator do the work. So we're going to go 28 squared plus 25 squared minus 2 times 28 times 25 times the cosine of 110 degrees. And of course that's going to be c squared is equal to my 1,880 7.8, but I'm going to square root both sides to get the value of that. Okay, so I square root that, and I get an answer of about 43.4. We'll say 43.4. 43.45. All right. So here's what I have. Here's what I'm trying to do. I want to use this formula. Okay. I'll use this formula, and to do this formula, I need 1/2 adjacent times the sine of the angle. Well, the angle has got to be that angle there. I don't have that angle here. Okay. I know the entire angle is 130 degrees, right? But I don't have that angle there. Okay. So the way I'm going to get that angle there is, I don't know, I'll call it angle A. If I can find angle A, if I can find this angle, I can subtract from 130 and get that angle. Okay, I'll say it again. If I can get angle A, which is that one there, I can then subtract it from 130 degrees and get this one here. We'll call that theta. Okay, that's what I want to find. So to get angle A, I'm going to set my opposites. Okay, I'm going to go opposites, opposite, opposites. Means the law of sines. Law of sines would go sine of A over its opposite side, which is 25, equals sine of 110 over its opposite side. Okay, remember how we did that? Opposites. That's what I like about this problem. It requires us to use all of our math. Let's multiply up to 25 to solve for that. Then A, sine of A, is equal to my 25 times my sine of 110 divided by my 43.45, right? Okay, let's do that. Calculator time, and 25 times sine of 110 divided by 43.45, and I get a decimal. Kind of anticipated that, because what I want to do is take the sine inverse of that answer, right, to get angle A. So I'm going to sine inverse of that answer, and I get about 32.8. Angle A is about 32.8. Okay, so what does that do? Well, let's go back up to here. Okay, if I know this angle is a 32.8 degrees here, then I can find theta. So to find theta, right, the whole thing is 130. This part of it is 32.8. So I just have to subtract 130 from the 32.8, and I'll get theta. Okay, so theta is equal to my 130 minus my 32.8. Let's see, 130 minus 32.8, and I get an answer of about 97.2. Okay. Okay, here we go. Now, let's find the area of this triangle, triangle 2. I can do that. My formula is 1/2 adjacent times the sine of the angle. That's my formula. I have adjacent, and I have the angle. So triangle 2 is equal to 1/2 adjacent, 20, times the other adjacent, 43.45, times the angle, times the sine of the angle, sine of 97.2. Okay, now, all right, and my 1.5 times 20 times my 43.45 times the sine of my 97.2, and I get an answer of about 431. Okay, so triangle 2 is equal to 431. Circle that. Now, the area, total area has got to be triangle 1 plus triangle 2, right? Because that makes up the total triangle. So my answer is going to be my 328.9 plus my 431. All right, let's see what I get. Okay, just add them together. 328.9. I get an answer of about 768.1 centimeters squared. Okay, now that's a decent problem. Okay, your homework has got that on there, so good luck to you. Finish strong. Okay, finish strong.